Hi there! This video is an exam paper walkthrough of the Edexcel GCSE Mathematics Higher Tier Paper 1 from Summer 2023. This paper is worth 80 marks in total, and this is the first video of 4. It will focus on questions 1 to 6, which account for 20 of these marks. Edexcel Paper 1s are non-calculator, so a calculator cannot be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 1. Work out 8.46 divided by 0.15. So first thing I'm going to do, I'm going to multiply 8.46 by 100 to make it 846. And because I've multiplied the left hand side by 100 and I'm dividing, I'm going to do the same to the right hand side, even though sometimes I might not need to. And then I'm doing 846 divided by 15. So 846 divided by 15, 15, 30, 45, 60, 75, 90. So 15's into 84. 1, 2, 3, 4, 5. To get from 75 to 84 is a remainder of 9. 15's into 96. 1, 2, 3, 4, 5, 6. With a remainder to get from 90 to 96 of 6. And then 15's into 60. 1, 2, 3, 4. So it's 56.4. Because we're dividing and I multiplied both sides by the same thing, that is my answer. I don't need to reverse it. Question 2. Work out 7 3/8, subtract 2.5. Give your answer as a mixed number. So the first thing I'm going to do is convert each of these mixed numbers into improper fractions. So 7 multiplied by 8 is 56, add 3. So I have 59 over 8. Subtract 2 times 2 is 4, plus 1 is 5, so that's 5 over 2. Now I want a common denominator. I'm not going to change this fraction, but I am going to multiply this one by 4 because 2 multiplied by 4 gives me 8. So then 5 multiplied by 4 gives me 20. So now I can do 59 subtract 20. So I can subtract the numerators and the denominator stays as 8. 59 subtract 20 is 39 over 8. Now it asks for our answer as a mixed number. So this is currently an improper fraction because the numerator is bigger than the denominator. So I'm going to see how many 8's go into 39. 8, 16, 24, 32, 40. So 1, 2, 3, 4 8s with a remainder from 32 to 39 of 7 8s. So 4 and 7 8s goes on the answer line. Question 3. A cube has a total surface area of 150 centimetres squared. Work out the volume of the cube. So to work out the surface area of the cube, we would have found the area of one of the faces and then multiplied it by 6 because 6 faces of a cube would be equal in area. So the first thing I'm going to do is I'm going to divide 150 by 6 because this will then tell me what the area of one of those faces is. So 150 divided by 6, 6, 12, 18, 24, 30. Let's see if that's enough. So 6 is into 15, 1, 2. The remainder to get from 12 to 15 is 3. 6 is into 30, 1, 2, 3, 4, 5. So 150 divided by 6 is 25. So the area of one face of this cube is 25 centimetres squared. Now the faces are squares, so I can find the side length because it would be x times x. We've multiplied the length by each other to get 25. So the square root of 25 is 5. So that tells me that each side of this square or each edge of the cube is 5 centimetres. So now I can find the volume because I would do the area of the face of the cube times by the depth of the cube, which is going to be 5. So 5 times 5 times 5 is 125 centimetres squared. Question 4. The table shows information about the daily rainfall in a town for 60 days. So here we've got rainfall and we've got the ranges of values. Here's the frequency. Draw a frequency polygon for this information. So we've got our y-axis, the vertical axis that's frequency, and the x-axis is the amount of rainfall. So when we're plotting a frequency polygon, we need to plot with the midpoints. So we want the midpoints of these ranges. So halfway between 0 and 5 is 2.5, between 5 and 10, 10 and 15, 15 and 20, 20 and 25. So we're going to go along to the midpoint, up to the frequency and mark a cross. Now, if you were struggling with the midpoints, you could add the two parts of the range together. So 20 plus 25 is 45, and then half that to get your midpoint. So along to 2.5 up to 8. So we'll just be careful with our scale. So here's 5, so that must be 2.5. That must be 7.5, etc. Just to make sure we're plotting it in the right place. So along to 2.5 up to 8, along to 7.5 up to 24, along to 12.5 up to 13, 17.5 up to 11, and then 22.5 and up to 4. So with frequency polygon, we're going to join those points together with straight lines. And then it's important because, just organise this paper, because we're drawing a frequency polygon, a polygon is a 2D shape. This is not a shape at the moment, it's just a lot of line segments connected. So we need to make sure we join the first and the last point directly as well, and that forms that polygon shape in our graph. Question 5. So we have the universal set that contains the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Set A are all the odd numbers that are in this set here, and B are all the square numbers in this set. Part A, complete the Venn diagram for this information. So we have a circle for A and a circle for B. The intersection in the middle is where we put any values that appear in both A and B. So let's have a look. A is odd numbers. So let's have a look for the odd numbers in this list. So we have A, 1, 3, 5, 7 and 9 are odd numbers. B is square numbers. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, so that's too big. So what we can see here now is the numbers that have pink and yellow are both A and B. So 1 and 9 need to go in that intersection in the middle. Anything that's just pink is going to go in the A circle here. So 3, 5 and 7. Anything that's just yellow, 4, is going to go in the B circle. And anything that's not highlighted, so 2, 6, 8 and 10, go on the outside of the circles like that. All values in that set need to be included, they just might not be within these circles. Okay, a number is chosen at random from the universal set. Part B, find the probability that this number is in the set B complement. So that little dash there is complement and it means not in set B. So we're looking for anything that's not within the B circle. So anything within that we're not including. So 1, 2, 3, 4, 5, 6, 7 numbers are not in B, and we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in total. So the probability that the number is in set B complement, that symbol is complement, so not in B, is 7 out of 10. Question 6. The scatter graph shows information about the ages and weights of some babies. So we have the weight on the vertical axis and the ages in months on the horizontal axis. Part A, describe the relationship between the age and the weight of the babies. So it's asking us to describe the relationship, not the correlation. So we have to explain what's happening. So what we'll notice is all of the points are moving in an upwards direction. So they're moving in an upwards direction, in a positive direction. So that tells us that there's a positive direct relationship between these two things. So as the age increases, so does the weight of the baby. So that's how we're going to describe it. So as age increases, so does the weight of the baby. Which makes sense, right? The older a baby gets, the more weight it's going to put on as it's growing and developing. So another baby has a weight of 5.8 kilograms. Part B, using the scatter graph, find an estimate for the age of this baby. So to be able to estimate from a scatter graph, we need a line of best fit. And what's important is your line of best fit follows the trend of the data. So if I drew a line like this across here, it's not following the trend of that data, so it wouldn't help me in estimating anything. So when we're doing this, we want roughly an average line. So we want roughly an equal number of points on either side. It doesn't have to be an exact science, and it doesn't necessarily have to go through any points, all of the points. It doesn't matter, as long as we have a line that follows the general trend of the data that we can use to predict from. So we've got a weight of 5.8 kilograms. So this is weight here. So I'm going to find 5.8. So 4, this is 5, so this is 5.8. And what I'm going to do is I'm going to read across to the line that I've just drawn, my line of best fit, and then read down from my line of best fit, and then I'm going to estimate this point here. So that's 2, 3.2, 4, 3.5. And it is an estimate. So if you were reading this off this question, you might get a slightly different answer depending on where you drew your line of best fit, but the mark scheme will have a range of values that you're allowed to be within. So they allow for that slight difference in your line of best fit, as long as you're trying to follow that trend of the data.